In this video, we're going to talk about two very important theorems, Rolle's theorem and the mean value theorem. Mean value theorem is more commonly used because it always works for any type of slope. Rolle's theorem is exactly the same thing, only it's for a very specific type of problem. And for both of these, the conditions are that f has to be both continuous and differentiable on the interval. But for Rolle's theorem specifically, my y values have to be the same. And what that does is when my y values are exactly the same, that means the slope between them has to be 0. And so what the theorem says is our derivative has to be the same as our slope at least once in the interval. So we could connect these with a straight line and our slope is always 0. If they're connected by something that is more of an angled line, again, what this says is the only way to get from point A to point B, if they're on the same y value, is to go up and curve back down at some point. So there must be somewhere where there is a horizontal tangent line. The mean value theorem works for any slope. So it doesn't have the condition that the y values have to be the same. But what it says is that our slope and our derivative have to be equivalent at least once in my interval. And so to explain that, think of like driving on the freeway. If we could calculate our average rate of change, that's our slope. If we could calculate that, maybe our average speed on the freeway would be, I don't know, 71 miles per hour. If we were to look at our exact speed, which is our derivative, it would have to at least be 71 at least once. So 71 miles per hour has to happen at least once. Sometimes we go a little faster than that, sometimes we go a little slower, but they have to be the same at least once. So our average has to be our exact at least once in the interval. And you can see from our picture, if we were to calculate the slope between 2 points, that gives me my average rate of change. There has to be at least 1 point in between the two at which the tangent line has to have exactly the same slope, at least once. So we're going to look at some examples. So first we're going to start with Rolle's theorem. Here are conditions. It has to be both continuous and differentiable. And the way we make sure that happens is just make sure the denominator is never 0. So because this is a polynomial, it is continuous everywhere. Once we take our derivative, we get 4x cubed minus 4x. That is also a polynomial, so it is differentiable everywhere. And now we just need to make sure that our y values are the same at the endpoints. So I'm going to plug in my two endpoints. I need to find f of -2 and f of +2. And I'm going to plug in -2 into my original function. And so here I get 16. Here I'm going to get 4 times -2. And we get a y value of 8. If we were to look at the next ordered pair, we're going to plug in +2 this time. And here, again, we get 16. Here we have 4 times -2. And we also get 8. So these are equivalent, which means the slope between them will be 0. And that's what Rolle's theorem says. Rolle's theorem says the derivative has to be 0 at least once in this interval. So we already found our derivative. Let's go ahead and let's take that and let's set it equal to 0. And the theorem says we have to get an answer. We have to. That's what the theorem says. So I'm going to take my derivative, which is 4x cubed minus 4x, and I'm going to set it equal to 0 and simplify. Again, the theorem says at least one answer has to be in this interval. So if we don't get any, that means we messed up. So here we can factor out a 4x. So I'll get x squared minus 1. And when I set this guy equal to 0, I'll get x equals 0. Here I'll get plus or minus 1. Our interval was from -2 to +2. And so you can see here we actually hit it 3 times. So that specific c value that we're looking for is going to be 0 and plus or minus 1. So example 2, now we're going to move on to mean value theorem. And mean value theorem says the same thing. Except here specifically, we don't have to check our y values, but we do have to find our slope. So our conditions for this guy is it does have to be continuous on the interval. Again, it's a polynomial, so it has to be continuous. It also has to be differentiable on the interval. So let's go ahead and let's make sure it is. So we get 3x squared minus 7, which is also a polynomial, so we know it's differentiable. So since we've met our conditions, we know that this has to be true. That's what the theorem says, is that the derivative has to equal the slope at least once in this interval. So we have our derivative. Let's go ahead and find our slope. And our slope is going to be from point A to point B. So we need to figure out what happens when we plug in 1. And if we plug in 1 to our original formula, we'll get 1 minus 7 plus 6, or negative 6 plus 6, which is 0. If we plug in 3, we're going to get 3 cubed minus 21 plus 6. And 3 cubed is going to be 27. So 27 minus 21 is going to be 6, and 6 plus 6 is 12. And so now we're just going to take our slope. So our slope is going to be the change in the y values. So I'm going to say 12 minus 0 all over the change in the x values, which is 3 minus 1, or 12 over 2, which is 6. The theorem says we're going to take our derivative, set it equal to our slope. So our derivative is up here, 3x squared minus 7, and I'm going to set that equal to positive 6. If I simplify, I get 13. If I divide by 3, I see that x squared equals 13 over 3, or x equals plus or minus radical 13 over 3. So now I just need to see if either of those are in my interval. So if we were to simplify that, we get x equals plus or minus 2.08. And we see that one of those is in our interval. So our c value that we were looking for, our special number, is going to be 2.08 is when this happens on our interval. Okay, so last example here, we have 2 patrol cars equipped. They're 5 miles apart. As the truck passes, its speed is 55. 4 minutes later, its speed is 50. Prove that the truck must have exceeded the speed. So first of all, we know the travel, the speed here, is both continuous and differentiable because he's driving. So we know the mean value theorem applies, and the mean value theorem says the instantaneous rate of change must equal the average rate of change at least once. And since we know 2 points, we know they are 5 miles apart, so they traveled. So if I were to come up with 2 ordered pairs so that I could calculate slope, I know here when time is 0, we can say maybe my position is 0. And then after 4 minutes, which is 1/15 of an hour, I was now here at 5 miles past there. So if we find our slope, we're going to do the change in y over the change in x, and I'm just subtracting 0 here. So I get 5 over 1/15, or 5 times 15 over 1. So if I simplify this, I get 75. So if my slope is 75 miles per hour, I know that my instantaneous rate of change has to equal that slope at least once in this interval.